Okay, now that we've got our basic graph constructed, let's figure out how to put everything else on it, because there's a lot of things that we need to put together so we can figure out what's going on with the graph. So the first thing that we want to do is I want to calculate out the slope. And so we know how to do that, the rise over the run. Well, I can calculate out E by saying equals the slope. And then as you go through here, this would be our X values versus our Y values. And so once I do that, that's how I'm going to calculate out my modulus. So we can either manually calculate rise over 1, or we can use the slope function. Now you need to make sure that you pick 2 points in the elastic region, because if you pick something in the plastic region, your curve will be off. But that's okay, because I have a way for you to check it, and it will make calculating out the 0.2% yield stress a lot easier. So to check your E, we're going to make what I call the modulus line. So, or as I've got listed here, the E stress line. And so how are we going to do that? Well, we're going to plot a straight line using your E, because it's y equals mx plus b. There. Let's try that again. Y equals mx plus b is the equation of a straight line. M is the slope. So we're going to calculate out our stress using our modulus as our slope. And so you can see here E, I have this as the range name for this cell here of my huge number of psi for E. I'm multiplying that by my strain. Now this is going to give me a new stress value. And so then what I'm going to do is I'm going to add that to my graph. I'm going to add a new data series with these being my new stress X points, these being my Y points, and it's going to lay on the curve. And so if it lines up with the linear elastic region, we'll be able to see that. So if I plot that line there, you'll see that that's off. And so that does not match up with my modulus, with what I would expect, because my modulus of elasticity should be right there. It's not. So if it doesn't line up, we need to go back and revisit our E value. So I'm going to go back to that equation that I used for my slope. I'm going to take less points, because I obviously picked something here in the elastic. I'm going to come back here, and I'm just going to keep reiterating that until I get something that looks a little bit more like this. And so now I have a line that pretty much approximates what my linear elastic region is going to be. This is also why you don't bury numbers in your equations. And I always check this when I grade that stuff to make sure that you're not, because if you just typed in your E value, you would have had to keep typing it in, typing in here. You just change it in the box. Everything changes. It makes it a lot easier. So we don't need all this dead space on the graph, so what do? Well, if I right-click on that axis, and then I will set the max and say, I don't need to go that high, set the maximum to be 150,000. And so then I will end up like this, much cleaner graph. And I showed you how to do that in some of the graphing examples earlier. So now what we need is, okay, well, we've got our modulus there. I want to calculate out my 0.2% offset yield strength. Remember what that is? That's the mathematical way that we determine what the yield strength is. And so it's a line that's parallel to this modulus line that we made that intersects at 0.2%, which would be 0.002 inch per inch. So how do we do that? We're going to go back in, and we're going to make another line. We're basically plotting the same line, but I'm going to shift the I'm going to shift the strain to the right by 0.2%. And so the way that I'm going to do that is I will take my modulus, and I'm going to multiply it by the quantity of my strain minus 0.002. And that's going to shift that line over for me. In fact, remember 0.002 is the decimal form of 0.2%. And so once I do it, I'm going to have something like this, which is great because now there's my line that mirrors my modulus of elasticity, and it's showing crossing the graph at 0.2%. Now what I want to do is I want to clip off the negative numbers. So once again, I want to right click on this axis and say, hey, make the minimum 0, and then I'm going to have a graph like this. And so this is what I want. Now I want to point out something. You notice each of these is labeled very clearly of what each line is. That's going to be important. So the next thing that we want to do is, how do we mark points? Because you have to identify elastic limit, 0.2% offset yield. Now, mind you, that line is not the 0.2% offset yield. It's where that line intersects the stress strain curve where it is. And I see that mistake all the time with students. That line isn't isn't the answer. It's that point where those lines intersect. Ultimate tensile strength, breaking strength, elastic limit. You have to mark all those. So how are we going to do that? I'm going to go back to our graph and we're going to add one data point. So what I'm going to show is I'm going to show you how to do the ultimate, because the ultimate is the maximum stress. So you want to go down there and find out what the maximum stress is. You can either look at the numbers. The easiest thing to do is run that max function to find out what the maximum stress is. So we found that this maximum is at 0.1315. So what I'm going to do, I'm going to go and add a series. I'm going to call it the ultimate stress, and I've chosen the point. I've given the x and the y values of the point, and then I've plotted it. Where is it? I can't see it. Well, remember, these are all lines, not markers. So it's just one point, which is a marker. We can't see it. So what you want to do is left-click on your one-point series, which is basically you click down here on the title to activate the title, and then right-click on it, and then you can bring up Change Series Chart Type. This is just going to change one series, not the whole chart, which is what we want to do because we want the other ones to still be lines. And so from there, we can go and change it to just a marker, which is a scatter. But now we need to make it bigger because we still can't see it. It's too small. So again, you left-click on that one-point series, then right-click on it to bring up your chart here. And then this time, we're going to go to Format Data Series. And so from there, we've got all the options. You should be familiar with this because it's the same in Word and everything else. And so you want to go to the marker menu, which is the little paint bucket. And then once you get there, click on marker. And then you can choose the size, color, and everything else. And that's all right here. And so you can play around to make it whatever you want. And in this case, I can see that I've got it there. It's a nice little point. Down here, we can see it's labeled as a point. I can easily see it. That's awesome. What you probably want to do here is then insert a text box and say, ultimate stress, give what the ultimate stress is with units. And now you have to do that for all the other ones.